Hi all, very good evening to one and all. So I hope internet connection and my voice is clear to you. So can anyone please respond in your chat box? Can anyone please respond, please? Okay. So let me introduce myself. My name is Jishnu, Assistant Professor Civilianz. So I am handling Geotechnical Engineering subject. So today we are gathered here to discuss some ISRO questions. I mean ISRO quick revision schedule. So for ISRO questions, so here for ISRO generally for 100 marks, maximum mark is 100. Within this 100 marks, 80 marks is for technical and the remaining 20 marks is for non-technical. Remaining 20 marks is for non-technical. Again within this 80 marks, again split up is there. 60 marks from pure technical and remaining 20 marks from technical, but it is from thermodynamics, that is related to geoinformatics, that kind of things that you already studied. It is not difficult, but it is technical from other subjects. So these are the mark distribution. So in the case of geotechnical engineering, by analyzing the past 4-year ISRO papers, here these are the number of questions generally they are asking. That is the 7 to 9 questions generally. Generally 8 questions. Total 8 questions. Okay. So if we analyze the past 4-year ISRO papers, in the case of geotechnical engineering, the questions and all are very easy, very basic questions. Everyone can do that questions very easily. But the main thing is you have to go through this all topic. That is the issue. They are asking very simple question. They are not asking very huge formulas, lot of concept questions. That and all they are not asking. But you have to go through this whole topic. These 14 sessions you have to go through. Okay. So this session we have designed for 2 hours. So at the end of this session, we will discuss the past previous year questions. At that time, you will get the idea, clear idea, at what level they are asking questions and all. So here our intention is to deal with all the important formulas, everything in a nutshell. So if you see this video for 2 hours, definitely 100% sure, please trust me, 100% sure, you will get this 8 question. So we are designed this 2-hour session like that. Okay. So these are the topics. First one is properties of soil. These are the flow of our topics. So you have to study like in this manner. That is properties of soil. So the main problem of geotechnical engineering is if you don't know these basics, you can't able to understand the remaining topic. That means consolidation, compaction, shear strength, earth pressure and all. Every topic is having some concepts. Okay, related to some concepts. Okay, without wasting time, directly we can jump to topics. Directly we can jump to questions. So through questions, directly we can study the formulas, basic concepts and all. Okay. So at the final, definitely we will discuss about the previous ISRO questions and all. So initially we will do some basic questions. Okay, first you try this. So the main thing is that you have to do in a very fast manner, and you just type in your chat box what will be the answer. Okay, so let's start. If you have any question, you just type in your chat box. Okay. Okay, this is our first question. So I will give you 1 minute for doing this. First you read this question and answer it very fastly. Everyone please take a pen and paper and try to do. Then only this session will be beneficial to you. Otherwise you are simply watching, it is like a cinema. First you try this question, then only you will understand. This question is very easy question. It will take hardly 60 seconds, not 30 seconds. Yes, one person get the answer. So here a sampler volume. Volume means total volume. Total volume V is equal to 45 centimeter cube with a dry soil sample. When the same soil is poured into graduated cylinder, it displaces 25 centimeter cube of water. It displaces 25 centimeter cube of water means what they are saying. If you take some amount of water into a beaker, if you drop this pen over there, if it displaces some amount of water, definitely we will get the volume of this pen. Same thing. So that means here in this case the soil Vs, that is 25 centimeter cube. This question is very direct question, very easy question. So what about the formula for void ratio? E is equal to volume of void divided by volume of solid. Okay. Then what about the volume of void? Volume of void means total volume minus volume of solid. So that is 20 centimeter cube. So here E is equal to 20 divided by 25, that is equal to 4 divided by 5, that is equal to 0.8. Many of you are getting answer. Very good. Okay. Can I ask one more question related to this void ratio? So which soil is having more void ratio? Fine grained soil or coarse grained soil? More void ratio. Can anyone? More void ratio. 1. Fine grained soil. 2. Coarse grained soil. In your chat box you just say 1, 2 like that. Yes, very good, very good. Many of you are answering. Fine grained soil. Okay, very good. Yes. So in this first chapter, so generally for ISRO, if you take 10 years, past 10 years question paper, generally they are dealing only with these initial properties of soil. So I would like to inculcate, you have to study these formulas by heart, that's all. Okay, so first formula, what we have studied? Anyone? Wg is equal to Es. Then these are the basic important formula. Gamma d is equal to G gamma W divided by 1 plus E. Then again gamma d is equal to gamma divided by 1 plus W. Then again gamma d is equal to G gamma W into 1 minus Na divided by 1 plus Wg. So these are very important formula. Most of the questions you will get by using these formulas. And then another most important formula is Here this one is site 1 and next this is site 2. So frequently they are asking this question, that is why I am saying without studying this, don't go to this ISRO examination. So site 1, so initial void ratio, that is E1, and then here gamma D is equal to at the site 1 is gamma D1, then here this one is E2, here gamma D2, this one is V1 and this one is V2. So before this, what is gamma D? Can anyone? And then what is gamma S? Most of the students may confuse these two things. What is gamma D? Gamma D means, I am not drawing the three-phase diagram and everything. It is a little bit boring because you people are already familiar with these kind of things. That is why I am not drawing that three-phase diagram and all. So gamma D means Ws divided by total volume. That is, this one is very important. Gamma D, gamma sat, gamma D means dry density, unit weight of soil. Gamma D, gamma sat, gamma, these kind of things are related to the pure site condition. Gamma sat, gamma D, gamma, these are pure site condition. Pure site condition, okay. So if we deal with this unit weight, you have to write here total volume. Okay. Then gamma S means this is just the unit weight of that material. If you take plastic, or if you take the density of steel, can anyone please comment the density of steel? What would be the density of steel in kilogram per meter cube? Can anyone? In kilogram per meter cube, density of steel. Please write in your comment box. Density of steel 7850. Yes, very good. Kilogram per meter cube. Very good. Abhiram, Adulya, Vaishnavi, everyone is saying. So that one is gamma. In the case of soil, gamma S, Ws divided by Vs, volume of that particular material. This one is gamma D. Then one more thing I need to clarify here is, this one is our ground level. Here water table is there. Here soil is there. Here water table. This is our ground level. So which condition we will write here? Gamma sub is also there along with this. That I forgot. So which condition we will write here? Gamma D, gamma sat, gamma sub. Which one we will write here? Can anyone please respond? Here water table is here. Which one we will write here? Submerged. Yes. Abhiram PS wrote submerged. 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 Fatima Nasser. Okay. One thing that I want to say here is, so these are the only site condition. These are the only site condition. Gamma sat, gamma D and gamma. There is no submerged. Submerged condition means that is not site condition. That is just if wherever you see the formula, gamma sat minus gamma W, at that time only you have to write gamma sub. Here, this one is not gamma sub, here gamma sat. Okay. Nivedya Peer wrote gamma sat. Very good. So this one is gamma sat. That is very important. Definitely some people may misunderstand that is gamma sub. Gamma sub means at the time of effective stress, wherever you see gamma sat minus gamma W, at that time only you will write gamma sub. Or directly we can't write gamma sub. Okay, so gamma sat, if water table is there, you have to write gamma sat. So this one is gamma sat here. So for gamma sat, one more formula is there like this. Can anyone? Gamma sat is equal to gamma W into G plus ES divided by 1 plus E. Gamma sat. So this basic you should know. That is very important. These are very basic things. In the case of geotechnical engineering, there are lot of concepts like this that you have to know. Then only you are able to do numerical questions. Questions are very easy. Questions will you can see in the case of geotechnical engineering, the questions will only 2 lines or 1 line or like that. Questions are very easy questions. But there are a lot of concepts within this. So this formula you need to by heart, and then here we stopped. So site 1, site 2. So this formula is very important. Every year frequently they are asking this. That I will write here. Site 1, and then site 2. Here void ratio is E1, volume V1, this one is gamma D1, here E2, V2, and then gamma D2. So if you are moving soil from here to here, definitely what will happen? Void ratio will change. So there are some relations connecting void ratio, gamma D, V1 and V2. So first one is gamma D1 divided by gamma D2, that is equal to V2 divided by V1, that is equal to 1 plus E2 divided by 1 plus E1. Okay, it is very easy. Gamma D means WS divided by V, that is why inversely proportional. Then one more formula is there, G gamma W divided by 1 plus E. So this one is directly proportional. If you write V2 here, E2 here, V1 here, E1 here. Did you get what I am saying? So this formula is very important. Most of the questions we can try this by using this formula. Okay, so let us try this question. Try this question. First find out the answer of question number 1. Then question number 2. Try to find out this. Whenever you get the answer, you just type it in your comment box. Do it very fast. First you just draw the 3-phase diagram. It will give you clue. If you are very slow in calculation, you can use calculator, no issue. This is just a quick revision. So here we are trying to check your memory capacity, which formula you know. Do you remember all the formulas and all? First answer. Nobody is answering. Option D is the first answer. Abhiram PS is answered. Shibna is answered. Shibna option D. Again. Second question answer is C. One more person if one. Right. Okay. A cube of dry clay having side 5 centimeter long. So here 5 centimeter long means dry clay. They are saying dry clay only. So dry clay means it is like this. What about the volume here? 5 into volume is equal to 5 into 5 into 5. That is equal to 125 centimeter cube. So that is 125 centimeter cube. Here volume is 125 centimeter cube. Then weight. Weight of soil means here 135 gram. Is it okay? Weight is 135 gram. Same cube of soil when saturated and unchanged volume. Unchanged volume means same cube of unchanged volume. Same fully saturated. When saturated means fully saturated. Here in question, if they mentioned saturated, means fully saturated. They can't mention fully saturated like that. Saturated means fully saturated. If it is partially, definitely they will mention partially saturated. Okay, so here also same, weight of soil is same. It can't change. Weight of soil can't change. Unchanged volume, weight. So here total weight is, they have given 195 gram. So what about the weight of water? Here, weight of water. Weight of water is 60 gram. Is it okay? 195 minus 35, 60. In question they have given 195, 60 gram. Yes, Vaishnav. So we have already studied density of water. 1 centimeter cube of water or 1 gram of soil, water occupy 1 centimeter cube. Okay. 1 gram of water occupy 1 centimeter cube. So 60 gram of water will occupy how many volume? How much volume? 60 centimeter cube. So what would be the volume here? Here 60, total 125. Here they have given without changing the volume. So here 65. Did you get this idea? Did you get the idea of this? 1 gram of water occupy 1 centimeter cube. Yes, very good. Shibna. Yes, Nivedya also saying 65. Very good, very good. Now everything okay. Specific gravity G. Specific gravity of soil G is equal to gamma S divided by gamma W. So what about the value of gamma S? Gamma S is equal to Ws divided by Vs. WS 135 divided by VS 65. WS divided by VS. How much you will get? 2.07 gamma S. Gamma W means here density I am taking. I am simply writing the formula, that is rho S divided by rho W. Rho W is 1 gram per centimeter cube. I am simply writing the formula. So here 2.07 divided by 1. So the answer is 2.01. First answer. Next, void ratio of the soil is volume of void divided by volume of solid. Volume of void divided by volume of solid. 60 divided by E is equal to 60 divided by 65. That is equal to 0.92. Did you get the idea? Here the only key point is, if a student know 60 gram of water occupies 60 centimeter cube, definitely within seconds they will get the answer. Okay, we are not using any formulas. No formula. G is equal to gamma, D is equal to that kind of formula we are not using. Just a concept you have to use. Okay, shall we move to next question? Please respond. Is there any doubt? You just ask in your comment box. Shall we move to our next question? Okay. Yes. Try this question. Beautiful question. For every competitive, most of the competitive examination, you can see this question. So if you take a 5 exam, minimum 2 examination they will ask this question. In 2 papers you can see this question. So what is the answer? Option A. Shibna is saying option A. Yes. One more, please. Yes, Harinarayan is also saying option A. Yes. Actually, I included only very few questions, basic questions, because for ISRO they are asking very basic questions. They are not going into this much level. They are simply asking what is shrinkage limit, what is gamma D, what is gamma set, that kind of questions they are asking. So every students will get, most of the students, those who those who went for gate coaching, state PSC coaching, definitely they will get 8 out of 8, 100% sure. It won't take time. Okay, so class void ratio. Here void ratio they have given. So before that, you should know what is shrinkage limit. Shrinkage limit means, are you familiar with this? Graph. Here water content, here volume. So here this water content, that is shrinkage limit. If you write 3 things, that is plastic limit, liquid limit. So here this volume is VD. So shrinkage limit means it is the minimum water content at which soil is 100% saturated. So if we draw the 3-phase diagram of here you can see dry soil. If we draw the three-phase diagram at this particular portion, without changing volume, without changing the volume, here some amount of water is there, partially. Here within, from this region to this region, soil is partially saturated. Did you get the idea? Soil is partially saturated. So at this particular point, within this void, the soil will occupy full of water. So that is why we are saying minimum amount of water content at which soil is 100% saturated. Did you get the idea? That minimum is very important. So minimum water content soil is 100% saturated. So here in this question they have given the value of shrinkage limit. They have asked the value of shrinkage limit. So here the key point is, so at this particular point and dry state, at this particular point and dry state, what will be the soil condition? Volume are same. Here the volume are same. There is no change in volume from here to here. So automatically, here void ratio is E. What would be the value of void ratio here? That is also E. So definitely we can write the formula Wg is equal to Es. Our intention is to find out the water content at this particular portion. The key point is void ratio at here and here are equal. That's all. So void ratio they have given. Soil is fully saturated at this particular point. Soil is fully saturated. So W, that is equal to W shrinkage limit into G, that is equal to E. S is equal to automatically 1 fully saturated soil. So E is equal to 0.5 divided by 2.72. So what would be the answer? 0.184 is the answer. So for every competitive exam, if they ask question, if they are asking questions from this particular topic, means liquid limit, shrinkage limit and plastic limit, the most important question they will ask from this shrinkage limit. Okay, so you have to study shrinkage limit in geotechnical engineering, that particular topic, liquid limit, plastic limit and shrinkage limit. You have to study shrinkage limit. Okay, so at a glance we can say, so what is the liquid limit? What I am elaborating this particular portion is, past 10 years they are asking only questions from this particular topic. That is why if a student just study these basics, properties and all, definitely they will get minimum 4 questions. So that is why I am elaborating, not simply going with the formula and all. So here water content, volume, W shrinkage limit, water content shrinkage limit, plastic limit, liquid limit. Then what is liquid limit? What is liquid limit? Yes, very good. 2.7 kilopascal or 2.7 kilopascal. So it is the water content at which. So I am expecting that kind of answer. Not water content at what is the boundary of water content between soil change from liquid state to plastic state, not like that. So that is the correct answer. Vaishnavi is answering shear strength of soil is equal to 2.7. Very good, very good. So it is the water content at which the value of soil having arbitrary shear strength, that is equal to 2.7 kilopascal. So here at that particular point, the value of shear strength is equal to 2.7 kilopascal. So anyway, liquid limit means we can mix the soil with water. So at that particular point, if you mix any soil with water, at that particular point, liquid limit means at that particular point, the value of shear strength is equal to 2.7 kilopascal, that's all. So that is why while doing Casagrande apparatus, so for finding out the liquid limit, we are using Casagrande apparatus. So that is why while doing Casagrande test with the Casagrande apparatus, they are taking 25 number of laws. So at that 25 number of law, the soil will attain 2.7 kilopascal. So one more definition is there. It is the water content at which water content corresponding to 25 number of law in a Casagrande apparatus. So if someone asks you what is liquid limit, at the time of interview you have to say this kind of answers. That is very important. Okay, liquid limit. Then plastic limit. Plastic limit. It is a water content at which we can mold an arbitrarily fixed shape of which dimension? Of size 3 mm. So that is why we are saying thread test. Here arbitrarily fixed shear strength. Here arbitrarily fixed size. Yes, Vaishnavi is answering 3 mm. Very good. I am very happy. Then shrinkage limit that we have already discussed. It is the minimum water content at which soil is 100% saturated. Okay, at this particular water content, we can mold that soil into different shape. We can deform that soil into different shape without breaking or without cracking. We can mold that soil into different shape. Okay, did you get the idea? So these things are very important. And then another important thing is some indices are the liquidity index, plasticity index. The first one is plasticity index, IP. IP. WL minus WP. Shrinkage index. WP minus WS. Toughness index. IP by IF. Toughness index IP by IF. Then liquidity index. These two are very important. Liquidity index. W minus WP divided by IP. Then consistency index. WL minus W divided by IP. Okay. So these two are very important. Most of the exam they will ask these two things. Liquidity index and consistency index. But plasticity in geotechnical engineering, plasticity index is very important. But for exam point of view, these two are very important. So look at this liquidity index, W minus WP divided by IP. If we add these two, IP, IL plus IC, that is equal to 1. So at least you have to study these formulas. You have to remember this formula before going to exam. Okay, that's all. So what you have to do is you daily you have to go through this formula. That's all. Once you wake up at 5 o'clock or 6 o'clock, you do one thing. You have to just go through this formula. You have to go through this formula in your formula book. Okay. Try this question. Beautiful question. You can use calculator also, no issue. It will take hardly. It will take only 1 minute. It will take only 1 minute. Not a essay type question. It is not a essay type question. Very easy question. Try this. Once you get the answer, you just type in your comment box. Vaishnav, Shibina, what about the answer? Are you trying? Option A. Archana is saying option A. Is there any other answer? Vaishnav E. Option A. Okay. Let me try this question. Option A means 100 centimeter cube. So 100 centimeter cube clay sample has natural water content. So volume they have given V1, that is equal to 100 centimeter cube. So in our classroom we have did almost 30 to 60 questions like this. Okay. Water content. W1 30%. Then shrinkage limit at that time. So here this question is pure conceptual. If a student have the correct concept, definitely they will get the answer within seconds. So liquid limit they have given, that is 18%. Liquid limit they have given 18%. Specific gravity they have given G is equal to 2.72. Specific gravity they have given 2.72. What will be the volume of the sample at the water content is equal to 15%. That are here 15% means here. 15% means here. Then what would be the volume here? Here you can see at 18% and 15% the soil is having same volume. So what we have to do? We have to find out the volume at this particular water content. Did you get the idea? Here the same volume at 18 and 15% same volume. Soil is having same volume. Questionnaire has asked what would be the volume of sample at 15%. At 15%, what would be the volume water content? W2 is equal to 15%. What would be the volume? 15% means 18%. If you find out the 18% volume, that's okay. So here soil is fully saturated at this particular water content. So Wg is equal to Es. So definitely here you will get the value of E1. What would be the value of E1? E1 is equal to 0.3 into G, 2.72. So what will be the answer? 0.3 into 2.72. 0.816. E1. Then next water content they have given W2 or WSL, that is equal to 0.18. G, there is no change in our G, 2.72. So we can consider this as E2, that is equal to 0.18 into 2.72. So that is 0.18 into 2.72. 0.489. E2 0.489. So here we know V1, E1, E2. We need to find out V2. We need to find out volume corresponding to this void ratio. How? Which relation we will use? Which relation we will use? V1 divided by V2, that is equal to 1 plus E1 divided by 1 plus E2. So here V1 is 100. V2 that we need to find out. 1 plus E1. 1 plus E1 means 1.816 divided by 1.489. So 100 into 1.489, 148.9, 148.9 divided by 1.816. 81.99. 82 is the answer. 82, C. Option C. Then how you get 100 centimeter cube? What is the logic behind that? Is it clear? Is it clear? So this formula is very important. V1 by V2 is equal to 1 plus E1 divided by 1 plus E2. Indirectly, we can apply this formula many times. Okay. Yes. This question is from CV analysis. Try to find out. Okay, thank you, Shivana. It will take only 30 seconds for doing this question. Try to find out. First you write all the data they have given and try to find out this question. No. Yesly, no. Okay. Yesly first commented no, then C. Okay, C. Yes. I thought Yesly you didn't understand the last question. That is why I am asking. Did you get the last question? Yesly, did you understand the last question? Okay. Data from the sieve analysis conducted on a given sample of soil show that 67% of particle pass through sieve number 200. Sieve number 200. So sieve number 200 means, what is that sieve number 200? Sieve number 200 means sieve size. How much? 75 micron. Then sieve number 4. 4.75 mm. At least you have to study these two sieve number. Okay. Can anyone explain what is the connection between this sieve number and sieve size? Is there any connection between sieve number and sieve size? Please comment. Quick. Comment it in a short way. Yes, very good. Vaishnavi is saying. So number of holes per inch. Exactly. So here number of holes per inch. Take just one linear inch dimension. Just count the number of holes. If you take linear inch dimension of 1 inch, if it is 75 micron size hole, you can see 200 number of holes. Here for 4.75 mm, sieve number is 4. Sieve number is 4 means 4 number of holes. That's all. Okay. Then here in this question they have given the data like this. So here we have to use the plasticity chart, A-line formula. So this A-line formula itself they have asked several times. No need to draw the A-line plasticity chart and all. But you have to study this A-line formula. So IP is equal to 0.73 into WL minus 20. Okay, 0.73 into WL minus 20. So what would be the value of IP by substituting this WL here? 29.3. Then IP by using our usual formula. IP is equal to WL minus WP. WL means 60 minus 40, that is equal to 20% here. What do you have to look? Whether this value is greater than or less than this A-line formula IP. If it is below A-line, that soil is silt or organic. Did you get the point? So here this value is less than 29.3, that is 20. So it means that soil is silt or organic. Just check in your option if it is silt or place there. So we can remove these two. Either this one or this one is our answer. Then just to look the liquid limit value. Here the value of liquid limit is less than 35%. It is low compressible. If it is between 35 and 50%, it is intermediate compressible. Then if it is greater than 50%, highly compressible. So here greater than 50%, 60. So here silt, highly compressible silt. The same question they asked in our last Kerala State PWD examination, Kerala State PSC PWD examination. Same question they asked. The same question that we did in our class also. Same question, without changing the numerical value. Okay. Sometimes they will ask directly A-line formula. What is A-line formula for IP? Sometimes they will ask velocity chart. Sometimes they will ask what intermediate compressible means. The value of liquid limit between, or highly compressible means the value of liquid limit means liquid limit between or greater than 50% or something like that. Okay, this question is very important. You have to study this question. You have to just mug up this question. Okay, try next question. What is the answer? Quick. One word type of question. Just read this. Flow through the soil is laminar when? Reynolds number is less than 1. So in the case of pipe flow, what would be the value of Reynolds number, pipe flow? Just command it, Reynolds number should be less than, just command it that number. In the case of pipe flow, just command it that number. In the case of pipe flow, yesterday you have studied, Anand sir already took pipe flow. Water flowing through pipe. Yes, 2000. In the case of open channel flow, Reynolds number, just comment it. Many of them are commenting. Nayana, Shibna, Vaishnav, Harinarayanan, Fatima, Nazar, Nivedya. Very good. Yes, 500. Yes, then what about if water is flowing through a plate? Reynolds number. Flow should be laminar. What will be the value? Water is flowing through a plate. Water is flowing through a plate. Comment it. Here this one is pipe, round pipe, circular pipe. Here this one is open channel flow, that is 500, very good. Most of you are answering. Then plate, how much? That is 5 lakh, 5 into 10 raised to 5. Yes, very good. Adulya MS is saying 5 into 10 raised to 5. Very good, Adulya. Okay, that's all. These are the things that you need to remember in the case of Reynolds number. Okay. These are the previous questions: pipe flow, open channel flow, plate flow, and all. Yes, so try this question. During permeability test on a soil sample with a falling head permeameter, equal time interval are noted for drop from H1 to H2 and again from H2 to H3. Then, condition. C is the answer, they are saying. Yes. So here, permeability K is equal to AL divided by AT into log H1 by H2 to the base E. That is the equation. So here in this question, this one is H1 and this one is H2 and this one is H3. Actually, this session is just a revision. if you don't have thorough knowledge regarding this permeometer, hydraulic gradient, this and that kind of thing, definitely you can understand. Okay. So once you sit in our classes and once you are familiar with all the concepts, then only you will understand what we are saying. Otherwise, students, they won't understand what is this line, what he is saying. Okay. So first you study the concept, what is falling head test. Then how this formula arrived. So here, this one is H1 and this one is H2 and this one is H3. So here in this question, they have given this one is T, same time. Time is the same. So we can write T is equal to AL by KA into log H1 divided by H2 to the base E. So both the time are equal, H1 to H2. Then again we can write AL by KA into log H2 by H3 to the base E. So here we can write H1 by H2 is equal to H2 divided by H3. So here H2 square is equal to H1 H3. Option C is the answer. So most of you may think that H1 plus H3 by 2, that is the answer. H2 means if same time, if it is same time, but it is not like that. Here logarithm came, so that is why H2 square is equal to, or H2 is equal to root of H1 H3. So many times they ask this type of question for ISRO, SSC, JE, that kind of examination. Okay. So this one is falling head. If it is constant head test, what is formula? Basic formula we are using. Q is equal to K into I into A. Basic formula. Yes. What is the unit of coefficient of absolute permeability K? Anyone please respond? Yes. Vaishnav and Shibna answered already. So here the question is the unit of coefficient of absolute permeability. Absolute permeability, or it is otherwise called as intrinsic. So here the unit is meter square. Intrinsic permeability, the unit is meter square. Meter square, centimeter square, or something like that. So permeability, here we are saying in geotechnical engineering, simply permeability means coefficient of permeability. Coefficient of permeability. So unit of that coefficient of permeability means meter per second square. Q is equal to, or V is equal to, or meter per second, sorry. V is equal to Ki. Okay. So this one is intrinsic permeability or simply permeability. Okay. So here this permeability and the permeability that we studied is entirely different. Here this one is related to that particular solid material. So in soil, what we are doing, in between what our fluid is flowing, that is related to our fluid. So here this one is related to that particular material. So here this concept, this absolute permeability or intrinsic permeability concept is mainly used for mining purpose and all. Okay, if you just type in your, if you just search in your Google, you definitely you will get the definition and all. Definition is very little bit huge. That is why I am not elaborating that particular topic. So for mining engineering, that kind of studies, they are using this absolute permeability. Okay, in geotechnical engineering, that is related to fluid. Here we are not dealing with that. Here we are not dealing with a particular material porosity. So that absolute porosity, that is related to that particular material. Here the fluid that is flowing here along with this particular fluid, we are dealing with that particular fluid, related to that particular fluid and material. That is hydraulic conductivity. So that here, that is hydraulic conductivity. So unit is meter per second, centimeter per second, or something like that. Okay, in hydrology, sometimes you may study this. In that hydraulic conductivity topic, one topic is there, hydraulic conductivity, that aquifer, confined aquifer, unconfined aquifer. In that particular topic you will study this. Okay. Then seepage analysis is done on the assumption of. What is the answer? Seepage analysis is done on the assumption of. Seepage analysis means, what is seepage? Flowing of water. So here in our case, the water will flow from top to bottom or bottom to top. So these are the two cases seepage means. So here the critical condition is, here two flow is there, upward flow and downward flow. Upward flow and downward flow. So which one is the critical condition? Water flow through the soil, upward or downward, which one is the critical condition? Here upward is the critical condition, upward seepage is critical condition. At that time only the value of effective stress will become 0. So that is the critical condition. So seepage, that is very important for any exam point of view. That particular topic is very important, seepage analysis. So for doing, if you want to deal with consolidation analysis or settlement analysis, you should know seepage analysis, effective stress, permeability and stress distribution. If a student don't have very good concept about this particular topic, they can't do the consolidation analysis and all. Sometimes they may ask simple formulas and all. For ISR it is okay, for GATE and all it is not possible. Okay, for GATE, engineering service examination, it is not possible. You should know the clear concept. Okay, then only you can answer that kind of question. Okay, anyway, for seepage analysis you should know the first basic formula, critical hydraulic gradient. That is very important. Directly I am jumping into that, critical hydraulic gradient, IC. What is IC? At that particular hydraulic gradient, what would be the value of effective stress? Please comment. What would be the value of effective stress? Can anyone please comment? Yes, 0. So at this particular point, the value of effective stress is equal to 0. So here you will get upward seepage, gamma sub into Z minus gamma W into HF is equal to 0. So this one is HF. HF means head loss. Here I am not drawing the diagram, not saying how we will arrive this formula and all. So that you have to study, because we don't have that much time. Okay, definitely if you are directly sitting in this class or simply sitting in this class, if you don't know the clear idea about this seepage analysis, how to find out the effective stress, you can't understand what I am saying. 100% sure. 100% sure. Okay, so first you have to study all the concepts of effective stress, seepage analysis, how you arrive this formula and all. Then watch this video. Okay, so by rearranging this, gamma sub into Z is equal to gamma W into HF. So HF by Z is equal to gamma sub divided by gamma W. So this HF by Z, that is equal to IC, first formula, gamma sub divided by gamma W. This is our first formula. If you know the value of gamma Z, within second you can find out the value of IC. Did you get the idea? If you know the value of gamma Z, directly you can find out the value of IC. One more formula is also there. Here IC is equal to gamma Z minus gamma W divided by gamma W. If you substitute gamma Z is equal to gamma W into G plus E divided by 1 plus E. G plus E divided by 1 plus E here. You will get one beautiful formula, that is equal to IC is equal to IC is equal to G minus E divided by G plus E minus 1 divided by 1 plus E. So while rearranging this, G minus 1 divided by 1 plus E. You have to by heart this, G minus 1 divided by 1 plus E. Yes. While rearranging this, you will get the formula like this, G minus 1 divided by 1 plus C. So these two formula you have to by heart, critical hydraulic gradient. Okay, every year frequently they are asking this type of questions. Okay, for ISRO, this much is sufficient. For GATE and another competitive examination, ESE, you have to study how to find out the value of effective stress. While water is flowing in upward direction, while water is flowing in downward direction, and then what would be the value of pressure head, then total stress datum head, everything. That you should know the concept of that kind of thing. Then only you are able to do the questions, numerical questions. Okay, now try to find out this question. Uniform sand stratum 2.5 meter thick, has specific gravity 2.62 and natural void ratio 0.62. Hydraulic head required to cause quicksand condition in the sand stratum. Option C. Adulya MS, option C. Nayana C. Yes. So here same equation. IC is equal to G minus 1 divided by 1 plus E. So here G that they have given 2.62 minus 1 divided by 1 plus E, 0.62. So while solving this, IC is equal to 1. So IC means HF divided by Z, that is equal to 1. So here this one is very important, the hydraulic head required to cause quicksand condition. Hydraulic head required to cause quicksand condition means HF. Head required to cause quicksand condition. That is HF is equal to 1 into Z, that is equal to Z means 2.5. So answer is 2.5. So sometimes you may confuse, H means head of water in the piezometer. So here in this question they didn't mention that head of water in the piezometer, that is here. Just understand this terminology, the hydraulic gradient head required to cause the quicksand condition means the HF. So HF means head loss, or sometimes they may use this word, or another word they are saying head causing flow. In questions they may ask head causing flow. Sometimes they may say head causing flow, head loss, head required to cause quicksand condition. Their intention is head loss HF. You need to find out the value head loss. Yes, that's all. What is the answer? Flow net is used to obtain. What is the answer? Flow net is used to obtain. Yes. Adulya is answered option C. So here flow net, only one formula that you have to remember. That is Q is equal to K into HF into NF divided by ND. This one is for isotropic soil condition. Then Q is equal to, so here flow in x direction, that is Kx. This one is flow in z direction, that is Kz. So that means anisotropic condition. So that means K dash into HF divided by NF divided by ND. At least you have to study these two formulas from this topic. Okay. So this one is for anisotropic. Anisotropic soil. So what about the value of K dash? Root of Kx into Kz. Can anyone say what is this NF and ND? NF, just type in your comment box. NF, number of flow lines, option A. Number of flow channel, option B. A or B? Number of flow channel or number of flow lines? Yes. Anaga, Adulya, Vaishnav, Shibna, everyone are saying option B. That is very important. Number of flow channel, that is B, and that is NF. So in question, if they have given number of flow lines, if number of flow lines is 5, number of flow lines is 5, then how many flow channels are there? Can anyone please respond? Yes, very good. 4 flow channel. So flow channel means it is like pipe. It is like a pipe. So if you put a pipe like this, water will flow in this direction. So what is the significance of this flow channel? So it tells us at what direction the water will flow. Direction. So if you put this pipe like this, water will go through in this fashion. So flow lines means like this. These two lines. These two red lines are flow lines. The space between these two lines, that is what we call as flow channel. Did you get the idea? So if 2 lines are there, only 1 flow channel. If 3 lines are there, 2 flow channels. Okay. By the same manner, ND means, what is ND? Equipotential lines or equipotential drop? Equipotential drop. Number of equipotential drop. So once you get all this value, by simply substituting this formula, you will get seepage. Once you know the value of equipotential drop, directly you can find out the value of how much water will be there in the piezometer. Or what would the value of HF, that also you can find out at that particular point. And effective stress also you can find out once you know the value of U. If you know the value of U, directly you can find out the value of effective stress also. Now you try to answer this. Now just try to answer this question. Flow net is drawn to obtain. Here there is no chance to find out the coefficient of permeability. Here while drawing this flow net, there is no way to find out the value of permeability. Once you know the value of permeability, you can find out the value of seepage. That you have to find out by using another method, by using permeameter, concentrated permeameter or something like that. Okay, once you get a permeability, then we can draw the flow net. So here remaining option C, all options are dealing with the coefficient of permeability. So the option C is the correct answer. Exit gradient, uplift pressure, and seepage quantity. Q, uplift pressure means once you get the value of U at different point, you can find out the value of what about the value of water in the piezometer. Then you can draw the pore water pressure diagram. You can draw. Then take the area of that pore water pressure. You will get the uplift pressure or uplift force. You can find out. Then exit gradient. At every point you can find out. Wherever you just keep the piezometer on that flow net, you can find out the value of hydraulic gradient also. So these are the significance of this flow net. So at least you have to study that formula. Q is equal to K into HF into NF divided by ND. Okay, that's all. Same question. That Newmark's influence coefficient for number of concentric circles are 10 and number of radial lines are 30 is. What is the answer? Option B. Vaishnavi is saying option B. Very good. Nayana option D. So what is influence coefficient I? 1 divided by total number of sectors. 1 divided by total number of sectors. So if a circle is there, if I have 1, 2, 3, 4 radial lines, okay. Okay. There's some technical issue. Okay, try this question. Numerical influence coefficient for number of concentric circles are 10 and the number of radial lines are 30. So here let us assume two concentric circles. Here number of radial lines is here 1, 2, 3 and 4. Total number of sectors, how much? 1, 2, 3, 4, 5, 6, 7 and 8. So how can we find out the total number of sectors from this? Number of radial lines, total number of sectors, that is equal to number of radial lines into number of concentric circles. So here number of radial lines is equal to 4, number of concentric circle 2, 8. So I is equal to, here we have formula 1 divided by total number of sectors. So 1 divided by how many number of sectors? 10 and 30. So 1 divided by 300. How much? 0.0333. That is the answer. Okay. Yes, so try this question. Try this question. Vaishnav, please respond. Is everything okay? I mean connection, network connection, my voice and everything. Please respond. Please respond in your comment box. Am I audible or not? Okay, okay. Thank you, thank you. Now try this question. Beautiful question. This question is a beautiful question. If you have clear concept, within seconds you will get the answer. What is the answer? Any idea? Maximum value of vertical stress on a soil on vertical plane at a distance of 1 meter from the point load. So what is the meaning of this question? What is the meaning of this question? Here this is our ground level. Here one point load is there, Q. And then here vertical plane, 1 meter from here. Vertical plane, 1 meter from here. So if I take a vertical plane here, at a distance of 1 meter from here, maximum value of vertical place, vertical stress corresponding to this vertical line. Where is it? So if we draw the vertical stress distribution, graph is like this. So here maximum value occur at here. What about this angle? Can anyone please comment? So this is the maximum value. What about this angle? Please comment that value. Very, very, very important. 39.15. Yes. Very good. Theta is equal to 39.15 degree. Very important. So this one is 1 meter. This x we need to find out. So tan 39.15 degree is equal to 1 divided by x. So x we need to find out. 1 divided by tan 39.15 degree. That's all. So 39.15 degree. What is the answer? 0.814. 1 divided by 0.814. So answer is 1.23. So try to remember this value 0.814. That is very important. So here for state PSC, Kerala state PSC or other state PSC examination, sometimes they may ask this type of questions. The students will remember this value, should remember this value, that is tan 39.15, that is equal to 0.814. Try to remember that, try to by heart that value in your formula book. You have to write that 0.814, tan 39.15 is equal to. Okay. Option B. Some students are saying a correct answer. Then, what is the answer of this question? Excess pore water pressure is also known as QC. Excess pore water pressure is also known as, that is hydrodynamic pressure, that's all. Option A, hydrodynamic pressure or excess pore water pressure. So here consolidation, if you are dealing with consolidation, here water table is here. If we keep our piezometer here, immediately after the application of load Q 10 per meter square, some amount of water will rise from here to here. Some amount of water will rise. So this one is U, that is static pore water pressure. Up to water table, some amount of water will rise. That is static pore water pressure. Pore water pressure that is studied in the effectiveness chapter. So immediately after the application of load, some amount of water will rise corresponding to application of this particular load. So this one is UE. So that one is excess pore water pressure or hydrodynamic pressure. We can call this as hydrodynamic pressure. So whenever this value excess pore water reaches here, so that means end of consolidation. So consolidation start means this excess pore water pressure will slowly diminishing. Whenever it reaches 0, means it reaches here at the ground level, which means consolidation is already occurred or at the end of the consolidation. That point is the end of the consolidation. Okay. So that is why excess pore water pressure is also known as hydrodynamic pressure. That is the question they asked. Okay. What is the answer of this question? Reduction of volume of soil, which is due to squeezing of water from void is primary consolidation, secondary consolidation, load increment, effective pressure. Primary or secondary consolidation? That is the correct answer. So answer is primary consolidation. So initial consolidation is there, primary consolidation is there, secondary consolidation is there. Initial consolidation means the consolidation that occur immediately after the application of load. That is sometimes the compaction, but the compaction or squeezing out of air or something like that. Immediate settlement. Primary settlement means, primary consolidation means that is what we are studying. Excess pore water pressure diminishing, the water squeezing out of water from the voids or something like that. Primary consolidation. Then secondary consolidation means that is after all the water is squeezing out, some plastic rearrangement occur in this case of soil. So that is secondary consolidation. Okay. So now directly we can jump into our ISRO previous year questions. Questions are very easy. So that you will get the clear idea about that. ISRO previous questions. (2018) they have asked question like this. ISRO 2018. Compression resulting from long-term static loading and consequent escape of pore water is known as. What is the answer? Answer it. Option A. Anyone will answer. Then next question. So that is why intentionally I didn't discuss the previous year questions, because our aim is to revise all the topic. Partially saturated soil means three-phase soil. Everyone, please, everyone should comment it. Comment the answer of this question. These questions. Then water content of a soil at which volume become constant. What is the answer? Shrinkage limit. Yes. Work out this question. 2013 they asked. In between they asked a lot of questions, but I didn't include here. Questions are very easy questions, that is why. Try to work out Harinarayanan, Vaishnav, Nivedya. Try to work out this question. Load dispersion, 2 vertical to 1 horizontal. 2 vertical to 1 horizontal means here a footing is there. This is of the ground level. So here load dispersion means like this. 2 vertical to 1 horizontal. So here let me write here, this one is 2 meter and here this one is 1 meter. Here also load dispersion like this. So 2 meter, Z how much? 1 meter depth. 1 meter depth. Here load Q that we need to find out, that is Size of the footing that they have given 2 meter by 1 meter. So load Q is 300 kilonewton. So we need to find out the value of vertical stress at this particular layer below the 1 meter below the footing. So 1 meter below the footing means Q 300 divided by. Here dispersion they have given. If we move 2 horizontal, 2 vertical, 1 horizontal. So for 1 vertical, 0.5 horizontal. So for 1 vertical, 0.5 horizontal. For 1 meter, 0.5 meter. Here also 0.5 meter. So 0.5 plus 0.5, 1, 2, 3. 3 into 2, 6. So 300 by 6, that is 50 kilonewton per meter square. Option C. Yes. The earth of soil at rest is proportional to. What is the answer? Earth of soil at rest is proportional to. A, B, C, D. Which option is the correct? Here they asked the coefficient of earth pressure at rest. Coefficient of earth pressure at rest. That is 1 minus sin phi. Coefficient of earth pressure at rest. K naught 1 minus sin phi. Ka 1 minus sin phi divided by 1 plus sin phi. Kp 1 plus sin phi divided by 1 minus sin phi. At least study these formulas. Then it is the answer of this. Slope of E log P curve of soil mass given as E log P. Yes. So slope of E log P means, if you draw a graph like this, sigma here void ratio log sigma dash. Here you will get a graph like this. Here the slope of this one is CC, compression index. This one is compression index. What this one is CV, coefficient of consolidation. Then coefficient of permeability, that is K. Compression index CC. Coefficient of volume compressibility MV. So CV is equal to, you have to study this formula, K by MV gamma W. Then MV is equal to MV delta V by V naught into delta sigma dash. Generally, if you study this formula by heart, you are able to do every questions from this consolidation. So then another formula, consolidation, important formula for consolidation is TV is equal to CV into T divided by D square. Then TV is equal to pi by 4 into U by 100 all square, if the value of U is less than 60%. So these are the formulas that you need to by heart in consolidation. Yes. Last question. Then after this we can wind up this session. Okay. Which one of the following condition is valid in the case of unconfined compression test in comparison to triaxial test? Right answer is last question. Then we can wind up. Yes. Here in this question, here you will get in the case of UCS, here you will get the shape of Morse circle is like this. Here sigma and tau. Here this one is sigma 3 and this one is sigma 1. So here the answer is, in the case of UCS, the value of minor principal stress. Minor principal stress means here there is no confinement. Sigma 3 is equal to 0. So that is why here the first option is correct. If they ask what about the value of QU? QU means this one. That is sigma 1. QU means sigma 1. So here if we draw the failure plane, it will go like this. So this value that is equal to Cu, radius that is equal to Cu. So directly we can write QU is equal to 2 into Cu. That is another very important relation. Okay, Vaishnav, that is correct. Okay, so now here we are going to wind up our session, Geotechnical Engineering. So what I am going to say here is, you have to go with all the formulas for ISRO examination. You have to go through all the formulas. That's all. That is enough in the case of Geotechnical Engineering. Definitely you will get, you are able to do all the questions. Okay, no issue in the case of Geotechnical Engineering for ISRO. For other examination, you have to deal with more important concepts. Okay. Okay, thank you. Thank you very much.